Thanks for the introduction, Arne, and welcome to my talk. I want to present today several solutions that we can offer with GeoDict 2025 in order to allow you to offload computation either to your own on-premises hardware or to the cloud. Namely, I'm going to be talking about three different solutions. First of all, the MathMarket Cloud, which offers you scalable interactive workstations right in your web browser. Followed by the GeoDict Cloud, which is a batch operation system which allows you to submit computation jobs directly from GeoDict to be executed in the cloud. And last but not least, I'm going to demonstrate the JobQueue, which allows you to host a GeoDict simulation server on your own on-premises hardware, so your data never leaves your company network. So as an overview here, you can see here for those used to an older GeoDict version, we now have this in the module dialog where you can run a simulation. We have extended this button cluster now, and of course the traditional way to run a simulation, if you're within FlowDict, would be to click the Run button, which executes the simulation right away on your local machine, on the machine that you're sitting in front of. But now we also have the Cloud button, which submits the job to the GeoDict Cloud. Then we have the JobQueue button, which submits the job to the JobQueue. And we have another solution, the MathMarket Cloud, which is not integrated in the GeoDict user interface, but runs in your browser. So to contrast these solutions, the GeoDict Cloud allows you to submit the simulation job directly to the cloud. The current structure will be uploaded together with your simulation settings and potentially your material database, and this job will be automatically executed in the cloud. With regards to setup, there's no additional setup required beyond your already existing local GeoDict installation. You basically just need to have a license and a corresponding account which authenticates you to the GeoDict cloud. And this is particularly well suited for running large parameter studies, as we will see later, because all the variations of your parameter study are running in parallel instead of in sequence as they would on your local machine. And all of this, the GeoDict cloud and the MathMarket Cloud, are backed by AWS. That's Amazon Web Services. The JobQueue again allows you to install to run a GeoDict server on your on-premises hardware and then submit computation jobs from any workstation within your intranet to that server. The advantage of this is that the data, of course, never leaves your company network. It is also easy to set up and can, if the company policy permits, actually be done by end users with a few clicks from within GeoDict. And the MathMarket Cloud then is a software as a service solution which provides you with scalable cloud workstations right within your browser. Does not require any local software setup, so you don't need to install GeoDict or any other software. And thanks to Gordon Burmester here that we are allowed to mention that it's used for a while now by an Austrian oil major called OMV. Now some quotes by our clients to motivate the requirements to go to the cloud. So from one division manager, we heard that our upper management asked us to remove all local hardware. Of course, that means all HPC hardware, all workstations. And they want to streamline the hardware so that every employee gets basically only a laptop, and any expensive computations should be run in the cloud. Another quote from an engineer at another company was that they currently need about 12 months to design a new product, and the management wants the engineering team to reduce this time to 3 months. And another aspect that's always mentioned with the cloud is companies that are trying to improve their CO2 balance by outsourcing their IT infrastructure to the cloud. As another motivational example, here is a parameter study that was already shown in 2017 by our customer Mann & Hummel. They did a parameter study across 180 generated structures within GeoDict. And for this purpose, they purchased a small on-premises cluster and distributed these jobs basically manually to the machines within the cluster. And this still took a long time. And nowadays, with our cloud solutions, those simulations could be running in the cloud totally parallel. So all of these 180 simulations could be run in parallel, which means that 75,000 machine hours worth of simulations could be performed in the time that a single simulation takes, which would be only 420 hours. Another application example comes from GeoDict. When you want to compute the relative permeability and resistivity index within GeoDict, the simulation of the conductivity and single-phase flow has to be performed for every saturation level. And this potentially takes hours for large structures. But the simulations for each of these saturation levels are actually independent of each other. So using the cloud, those simulations for all the different saturation levels could actually be computed at the same time, saving again a lot of time. What you can see here is a cloud usage pattern. It's a typical cloud usage pattern by a customer of ours over a period of 6 months. Where you can see the average number of active virtual machines on every day within these 6 months, and you can see that the computation demand fluctuates widely. So on many days there's only a single machine running, but then again there's peak days where the customer required 14 machines at the same time. And of course, the large advantage of the cloud is that it can easily adapt to these fluctuating workloads, because you get basically infinite compute. You get as much compute as you could want. And also that you can if a project comes up and there's a time critical, there's a deadline to run a large batch of simulations, of course the cloud can adapt to that demand, and all the simulations can be run in parallel and deliver results in a short time. Yep. And of course, you don't need to maintain on-premises hardware in order to be able to cover this potentially infrequent peak demand. So after this motivation, let me begin with the first product, the MathMarket Cloud, which provides you with scalable, interactive GeoDict workstations in your browser. What you can see here is the MathMarket Cloud dashboard, which allows you to start, stop, and manage your virtual machines in the cloud. And it also allows you to upload, say, a CT scan, and after computing the result, download the result, say the result of a flow computation. It's a software as a service solution, runs totally in your browser. You don't need to install any software locally. And it gives you on-demand access to powerful workstations with basically arbitrary hardware configurations, up to, I believe, 4 terabytes of RAM if needed. And within these workstations, you basically get direct access to a desktop where GeoDict is already licensed and pre-installed for you with all modules, so you don't need to have any worries about licensing. And if you click this. You can see here these 2 running virtual machines, and if you click the connect button next to each machine, it will open a tab in your browser which connects you directly to that workstation, as we'll see in the next slide. Here you can see again, I have my browser down here. The first tab contains the dashboard. The second tab is the connection to the first workstation, and the third tab is the connection to the second workstation. And you can see here that I can easily switch between these browser tabs and work interactively with these workstations, even with huge data, without any problem. And this solution is first and foremost, the solution is great for exploration, for getting used to GeoDict, for workshops, for example, and especially for interactive work. For example, importing a CT scan. So basically manually thresholding, using the AI features, filtering and things like that, things that you need, where you need interactivity for. Also for structure generation, for experimenting with different structure generation parameters, and for the visualization and exploration of results, as we can see here, where I've loaded a flow field which was computed in a grain structure. And it's also great for development projects because customers who work with us can get immediate access to, say, prototypical versions of GeoDict, because we can just upload them to the cloud and the customer can start can directly start a machine using that new prototypical version. And the customer can at the same time start a machine with the previous version and compare the results directly between these two tabs. Now here again, to exemplify that local hardware specifications, so your local machine does not matter when you're using the solution. Here you can see the results of a flow simulation and interactive visualization with streamlines on a 2048 cubed grain structure. And that machine running there is a 64-core machine with 500 gigabytes of RAM. And my local machine was just my 8-year-old Windows laptop with Firefox running. And one benchmark that we did that was, I think, already mentioned the last year, but we reran this in a different configuration since then. Just as an example, we used the same platform to run a huge Lear simulation on a machine with 160 CPU cores and 4 terabytes of RAM. Because we don't have such a machine in our company. So for the next product, the GeoDict Cloud, this is a batch operation system where you can submit your computation jobs right from your local GeoDict installation. So this does require local GeoDict installation. But when you are at the point that you want to run like a flow or mechanics simulation, instead of running that simulation locally, you can submit that job, including all the information that's needed to perform that job, to the cloud, and it will basically run in the background on your machine, and you are free to do whatever you want until that result is finished. And doing this is as easy as clicking on the cloud button down here instead of the run button. As you can see here, I have a fiber structure loaded in GeoDict, and as most GeoDict users will know, GeoDict always usually operates on the currently loaded structure. So I have a structure in memory, I go to the FlowDict module, and when I then run a computation, of course, the simulation will happen on that very structure. If I instead click the cloud button, then this dialog will open, and I can assign a project name and a job name for this computation job, just for identification purposes. And one option that I want to highlight is here, this upload current structure. This is automatically selected. This means that upon submission of this job, the structure that you have currently loaded will be uploaded to the cloud. And when it runs the simulation, it will load that very same structure and then run FlowDict on that structure. This means that almost all GeoDict commands, almost all computation-intensive GeoDict commands, basically work directly in the cloud in this manner, because they all work on the current structure. And what's also important is down here you can click the select button to select between a wide variety of hardware configurations, number of cores, RAM, and GPUs. So this is also suitable for, say, experimenting with GeoDict AI or training a neural network. So if you only need very little hardware for inference, you don't need to buy large GPUs for training if you can do the training in the cloud and then run the inference locally, for example. And then once you click the run button, the job will be submitted to the cloud. And after that happens, this cloud projects dialog automatically pops up. And for each job, you can see a row in this table, and you can see the state of that job. And all of the running jobs, as you can see, there are two simulations running. You have to imagine that there is a virtual machine in the cloud currently working on that job. And the completed job does not involve a running machine. It's just the results are stored in the cloud, and you can download them anytime. You can select like a bunch of these jobs and just download all the results at once if you want. And you can monitor these jobs, and you can look at the. Unfortunately, you do not get the GeoDict progress bar right now, but you can look at the ongoing log of GeoDict, so you can figure out what how the convergence of the solver is going, for example. And for those of you who are a bit more seasoned users who use the very macro functionality, so if you have a parametric GeoDict macro, you can use very macro. You can use very macro traditionally to enter a variable variation And then you can run a parameter study, which, for example, runs the macro for the cross product of all these values. So I have 3 values for this first parameter, 3 values for this parameter. So it will run 9 different simulations. But traditionally, if you click that run button in the macro dialog, the upper one, it will run this. It will run this macro sequentially for each of the parameter sets on your local machine. But now, of course, this functionality extends naturally to the cloud, because if you click the Run in Cloud button, then it will actually run a single machine for each of these parameters at the same time. So basically, you can expect to get your results for the whole parameter study in the same time that it would take you to run a single one traditionally. And what you can see down here. So this dialog, this is basically an extension of the dialog we saw before. This has in addition has this parameter table, which allows you to again verify all the parameter combinations that are going to run. And the number of rows in this table is just the number of machines that it's going to spawn when you click run. So basically all these 9 values, for each of these values, a separate machine will be started. Again, once you do that, the GeoDict Cloud Projects dialog will open. And in this case, I have actually waited until all the results are finished, but you can see that the whole parameter study basically ran in parallel. All these machines were started at the same time and approximately were finished at the same time. And then you can go and you can select all of these rows. Just press Control A. You can click Download Results, and you end up with these results on your disk, which has all the results neatly sorted into separate folders with the corresponding variable values for each of these experiments. And then, for example, you can just go take all the GDRs, depending on what you're doing. You can take all these GDRs. This was a flow simulation, you could just take all these GDRs from the folders, open them all in GeoDict, use the combine GDR functionality, and get an aggregated view of your whole experiment, basically. Last but not least, there's the GeoDict JobQueue, which is a self-hosted GeoDict simulation server. So this is a piece of software which we run on premises. There's no cloud involved in this case, but some of the functionality is very similar and actually uses the same user interface. So first of all, starting the server is as easy as opening this GeoDict JobQueue server dialog and clicking this Start Server button up here. This will actually spawn another independent GeoDict instance, which is then ready to accept computation jobs on your machine, or whatever machine you click that button on. And I can say that this is successfully used by a large multinational customer right now, basically 24/7. They have users from multiple sites, I think 3 different sites across the globe, which all submit their GeoDict jobs to this to a large or largish Windows server where the customer has installed a GeoDict with the corresponding license. And this, of course, this model of usage, of course, allows for pretty efficient usage of GeoDict licenses, because the server is pretty much always busy. Now, in order to submit a job to the JobQueue, similar to the cloud, you just click JobQueue instead, and a similar window will open where again you can define a project and a job name prefix. Again, you have the option to upload the current structure if necessary, and you have the option to select a machine. But of course, in this case, you do not select a type of machine as you would in the cloud, which selects the hardware configuration of a machine that is then spawned for you, but you select a concrete machine, a server from within your network, which currently runs the GeoDict job server. So it will then offer you a selection of the servers. If you have multiple servers in your network running, they will all be listed here. And this lists all the servers that you are authenticated for. So all the servers that you are allowed to submit jobs to. And you can see the current utilization, the free RAM, how many jobs are in the queue, etc. And you can then, based on that information, you can select a server. And then you click OK to submit the job to the server. So again, only authenticated users can use the server. And when you initially start the server, so when you click that Start Server button, you don't have to fear that anyone could just run code on your machine. This is you are the only authenticated user at that point. You are automatically authenticated, so you can actually submit jobs to your local job server running on your own workstation, but nobody else can. It's relatively easy to add users, but by default, this is secure. And actually, this is also a valid usage model. So instead of offering that server to all your colleagues, it's also a valid usage model to just run the job server on your own machine, and just submit one job after the other, and then go home. And the next day you find all the results. Basically, this is an easy alternative to scripting. Basically, in GeoDict, you can just submit jobs to your own server. You change some settings, load another structure, submit another flow simulation, etc., and then just let it run. Yeah, again for the JobQueue, we have a similar projects dialog, which shows you all your running and completed projects, and this will now aggregate all your projects across all the servers within your network. Of course, only the servers that are currently running. So it will contact all the servers that you are authenticated to, fetch all your projects, and show them in an aggregated view where you can manage them, download results, and also reprioritize them using these buttons. Yeah, and in addition, the administrator of the server, so that is actually there's actually this view. This is also the administration view. The administrator of the server, or rather the one who starts the server, is able to manage and reprioritize all jobs. This was a feature that was asked by several customers who tried the prototypical version of this system, that the admin would have the authority to basically manage the jobs of all the users on their server. Yeah. And this is basically my last slide, the conclusion slide, which shows you an overview, a comparison of the features, the pros and the cons of each individual solution. The MathMarket Cloud of all these solutions has the lowest hardware requirements, because all you need is basically a computer with a browser. You could also use a tablet or potentially your phone, depending on ergonomics, because all you need is basically a browser. You don't need to install any local software. And the solution is great for interactive visualization of large results, because it gives you an interactive GeoDict session where you can do everything that you could do with a local session, except potentially on much larger hardware if you want to. And it's also great for testing GeoDict on different hardware platforms. And of course, one of the cons is that depending on your company policy, is that of course the data is then processed in the cloud. Yeah. So data is encrypted at rest, data is encrypted in transmission, and we're fulfilling security requirements in that regard, but it depends on your company policy if that is allowed. Also, the MathMarket Cloud is not well suited for large parameter studies, because as you would if you had a set of computers in front of you, you would have to manage the machines manually. You start one GeoDict on one machine, you open the first data set, start the simulation, you go to the second GeoDict, and open the next file and start the simulation. So this is where the GeoDict Cloud is much better suited. For the GeoDict Cloud, you have, I would say, reduced hardware requirements, because you do need a local GeoDict installation, but you don't necessarily need hardware that is strong enough to run the actual simulations. You only need to be able to look at your results. If you only need to look at GDRs and never load a volume field, then even a very weak hardware would be enough for this. And it's as I hopefully demonstrated, using the GeoDict Cloud is basically as easy as local usage, because you just click the cloud button instead of the run button, basically. And it allows you to run many simulations in parallel, which is great for parameter studies. And you can always keep an overview of your simulations, the state of your simulations, and if they're finished, and download the results all in one go, basically. Again, because this is a cloud solution, the data is stored and processed in the cloud, even though it's encrypted. And this solution doesn't allow for interactive GeoDict usage because it's a batch system. The job is basically fired off into the cloud, and all you get is basically the results. And again, it does require a local GeoDict installation as the interface to submit your jobs. Then there is the JobQueue, which has the large advantage that any sensitive data can stay completely within your intranet in your company network. It is easy to set up and use, and it allows for streamlined use of your local hardware and licenses. So it makes efficient use of licenses if it's running 24/7, basically. But of course, one of the cons is it does not adapt to fluctuating demand because you cannot on short notice increase your hardware deployment, and it does require local GeoDict installation both on the server and the client machines. And right now, the jobs within the job server are run sequentially, but enabling parallelism is high on our agenda, so that's work in progress. And then last but not least, of course, you can also bring your own cloud. So we can also talk about integrating GeoDict within your existing cloud or cloud storage infrastructure, which yields to easy compliance with your existing policy. But of course, setting up and maintaining GeoDict and the license server, etc., requires some IT effort on that front.